So today we're going to learn on day 8 the idea of permutations and combinations. They're not the same thing. They have little differences. So let's talk about what we did yesterday. So how can I rearrange the 9 letters in the logarithm? Well, I could do the FCP 4, 5, 6, 7, 8, 9 and be like, well, no repeats definitely help. So this would be 9 times 8 times 7 times 6, 5, 4, 3, 2, 1, which is 9 factorial, which is this big number, 362,880 ways that I can do it. Okay? How about if I only wanted to use 4 out of the 9 letters from logarithm? So again, only 4 letters. I'm going to use FCP, fundamental common principle, and be like, my first spot out of the 4, I have 9 options. And then I have only 8 letters left, 7 and 6. And now I have 3,024 ways that I can do this. Okay? Now, when we rearrange letters, order matters when we arrange letters, because a different arrangement is a different word, even though not everything is going to be a word. Now on this link, on this page, there's a link to 2 videos. Video 1 is the better video. It will explain the 2 things we're going to talk about today: the differences between permutation and combination. It's not even a 2-minute video, and that's going to be important for us, what we're going to do today. Up first is permutation. It's kind of what we did already. It's arrangement in which order does matter. So basically what we did in our example above, order did matter. So order does matter for arranging letters, or when you have specific roles to play. Okay? Then you have to be in a specific spot. It looks like this key. I'm going to write it in this form. And it is a special key on the calculator. I'll show you in a minute. And the idea is that the N means the total number of items I have. The R is what's being selected. Okay? So we're going to use our special key on our calculator to do 9P4. And 9P4 means I have 9 things, and I'm only going to select 4 of them. It looks very similar to the example that we did before when we took the 4 letters out of the 9 letters of the logarithm. So yesterday we found that special factorial key. The NPR key is in the same spot. I'm going to go to math. I'm going to move over to probability, and this time it's number 2. And it gives you shadow boxes, and for my example it was going to be 9P4. And look what I get. I get 3,024, which is what I had before, and we'll explain why we get what we get. If you have an older calculator, really older calculator, you would have to hit the 9 at first, but I don't think anyone has one of those, so I think we're pretty set. If you'd have a different version calculator, you might need my help to find that key on your calculator. So 9P4, or 9 permutation 4, we got 3,024 ways, which is exactly what we got before for the previous example of the 4 letters out of the 9 of logarithm. So there is a special formula for NPR. You do not have to know the special formula because you have that special key on your calculator. You could always just use that special key. But actually it's n factorial over n minus r factorial, which means I start with n, I create r factors. So if I wanted to do NP4, NP4 really means, let me get my eraser, start with 9 and create 4 factors. So it would be 9 times 8 times 7 times 6, which is exactly what the previous example looked like for the 4 letters out of logarithm, 3,024 ways. That's what 9p4. So a lot of times I use a special key, but sometimes I don't because it's a lot of work to go get that key. So let's just use our special key for all this. So 10p2 is just going to be 90. 15p8 means I have 15 items. I only want 8. It's going to be a lot of ways. 259,459,200. 15p0 means I have 15 items. I don't want any of them. There's only one way to do that. Don't take any of them. 20p1 means I have 20 items. I only select one of them. Well, I can select one or the other or the other or the other. So I could do 20 individual ways. And 6p6 would mean I have 6 items. I want to select all 6 of them. I put this in the calculator, 720 ways. So let's go back and look at some of this stuff. 10p2 would be start at the number 10 and we create 2 factors, and look what we get, 10 times 9, which is 90. 6p6 means start at 6 and create 6 factors, times 5, times 4, times 3, times 2, times 1, which we also known as 6 factorial, and 6 factorial is that. So we have some generalizations. NP0, n items and select none of them. There's only one way to do that. NP1, n items and select only one of them. There's n different ways to do that. And NPN would be n factorial, whatever n was. So let's look at the cast of Snow White and the Seven Dwarfs. We have 16 students trying out for the 7 dwarfs. Now we're going to say each of them are created equal, even though they're not, because you definitely want to be Doc, he's the smartest, or you want to be Dopey, he's the comedy relief. But let's say they're all created equal, and the idea is that order matters for specific roles. Everyone has a specific role to play. So that would be 16p7 depending on who's where, and if this was Mrs. Janice, she would have a hard time because she would have over 57 million ways that she could cast these 16 players as the 7 dwarfs. Combination is the idea that it's an arrangement where order is not important. Order does not matter. Ooh, that's terrible. Let me fix that. Erase everything. Order does not matter, such as if you had volunteers, or we're going to learn when we put toppings or condiments on something. I'm sorry, putting ketchup and mustard on a burger is the same thing as putting mustard and ketchup. Just because I said in reverse order doesn't make it any different. Again, we have this key. It's a special key on the calculator. Same spot as before. N is the total number of items. R is the numbers being selected. Okay. And we're going to use this key. And there is a formula for it. And the formula is this. You never have to know this formula. But technically what's going on is taking exactly what we did before, the NPR, and now we're taking R, we're dividing by R factorial to get rid of repeats, as we did with the repeating letters that we did on the previous day when we divide out repeats. But you never have to know this formula. I mean, it's good maybe application to think about it, but we have the special key on the calculator. Okay, so Guido's offers 10 different toppings to put on a pizza. They have a special where you could put 3 toppings on for $9.99, not including double toppings and this and that. How many different 3-topping pizzas can be made? Order does not matter for toppings on a pizza. Like I said, if you ordered pepperoni and a sausage pizza, and someone else ordered a sausage and pepperoni pizza, they're going to make them the same way. Just because you set them in different order did not matter to the people making the pizza. So that means it's going to be a combination. There's 10 items total. I'm putting 3 on. And I'm going to put this in the calculator. Here's my special key again, math, probability menu. This time it's number 3. I'm going to do 10 C3, and we got 120 ways. So math probability has 3 special keys: the permutation key, the combination key, and the factorial key. Okay, so let's put these into our calculator. 10C2, and I put in the calculator, I got 45. 15C8, remember 15P8 was this huge number. Well, 15C8 divides out all these repeats, and I get a much smaller number. 15C0 is 1 because I have 15 items. I don't want to take any of them. There's only one way to do that. 20C1, again, if I have 20 items, I want to select one of them. I could do 20 individual ways. And 6C6 means I have 6 items, and I want to take all 6 of them, and order doesn't matter. There's only one way to do that. Now let's talk about what it means if we do that formula. Well, 10C2 is 10P2 dividing out the repeats of 2. 10P2 on the previous page was 90 over 2. And this last one, 6P6, and 6C6, and is 1. So let's look at what we have for patterns. NC0 means I have n items, I want none of them. There's only one way to do that. NC1, I have n items, I only want 1. I could do it n ways. And NCN, I have n items, I want all n items. There's only one way to do that. So what does it mean? If we go to a calculator, there's a very special pattern going on here. I put this in the calculator, 5C3, I get 10. I do 5C2, I also get 10. So 5C3 is equal to 5C2. And let's talk about why. What is going on here? Well, let's do 5C3. So 5C3 means I have 5 items. Let's pick 5 letters. 5 letters of A, B, C, D, and E. And 5C3, I'm only going to take 3 of them. I'm going to make out a list. So 5C3 means out of my 5 items, 3 are in, and I leave 2 out. And the order doesn't matter, so my 3 are in are letters like A, B, C, and D and E are left out. B, C, D, and D and E are left out. And I could go through and list all 10, but I'm not going to. So that's what 5C3, and there would be 10 ways I could do that. 5C2, we'll do over here, means I have 2 in and 3 out. And guess what? My 2 in could be the letters D and E, and my letters out could be A, B, C. And I could go ahead and list all 10 ways, but you could see that 3 in and 2 out, and 2 in and 3 out is basically the same letters. They're just switching positions of being in and out. So these both have 10 ways in which they're being done. So what does this mean for this problem? NCR, whatever N and R are equal to, is going to be the same as N C N minus R. As an example, 100C15 is going to be 100C85. I have no idea what they're equal to. I know they're equal to each other because this says out of my 100, 15 are in and 85 are out. And this says 100 are in. Out of my 100, 85 are in and 15 are out. It's the same idea either way. So we go back to our pizza problem. I'll make it bigger. What's another way I could have done this? Let me choose red. Let me go back up here. So 10C3 means I had 3 toppings on the pizza and 7 toppings were left off the pizza because I didn't pick them. I took the 3, I left the 7 off. So what's another way I could have done this to get exactly the same number? Remember, when I did this, my answer was 120. Another way I could have done this was 10C7. That's also equal to 120 because this would be 7 toppings on and 3 toppings left off. So 3 on and 7 off, and 7 on and 3 off will give the same result in this scenario. So permutation order does matter. So looking at these 3 letters A, B, C, and I rearranged them in different orders, this would create 6 permutation, because each different arrangement is a different way of doing something. Okay? Order does matter. But because they're the same 3 letters every single time and order doesn't matter, this is only one combination. And that's the difference. Combination will always be less than permutation, or equal to, but always never more. So let's look at what we have. When does order matter and when does order not matter for these examples that we're going to go through? So first, second, and third chair in a band. Those are specific roles. Since they're specific roles, it is a permutation. 5P3 is 6 ways I could do it. A 5-person committee out of 18 could be any order. Just 5 people. It's a combination. Who cares? 18C5 is 8,568 ways it could be done. 4 CDs out of 8 could be any order. That would be 8C4. Combination is 70 ways I could arrange those CDs. 5 alphas out of 15, again, is any order. Combination, 15C5, 3003 ways. Password. I'm pretty sure in my password my order matters and how I type my letters. That's permutation. 20C5. Oh, P5. That's my bad. Where's my eraser? Can't even find it. P5. I get 1,860,480 ways it could be done. And the top 3 runners advance to the state competition. Basically, if as long as you're in the top 3 in any order, you're making it to states. That is combination, 16C3, and 560 ways. Next I have, how many 4-letter arrangements can I do for card? Well, I'm pretty sure order matters, so it's 4P4, or 4 times 3 times 2 times 1, which is 4 factorial. I get 24 ways I could do it. How many ways can I rearrange these to get the card in that order, C-A-R-D? Only one way I can get that to happen. Let me get out of here. So the general definition of our probability is, how many ways do I get what I desire out of the total possibilities in the problem? Well, what do I desire? I desire the letter C-A-R-D in that order, and there's only one way to get the C-A-R-D in that order, but rearranging the letters of those 4, there's 24 ways. So if I have those 4 cards and I lay them out, I have 1 in 24 chance of laying out in the order C-A-R-D. So this final question, there's 2 ways to do it. One way is to use combination. So when I put out these flags, I can put them out in any order. So it's going to be combination. So I have 1, 2, 3 different color flags, white, blue, and red. And here are my possibilities, and there's some repeats going on. So at the very beginning, I have 8 flags. Combination 4 are white. Now I only have 4 flags left over. Combination 3 are blue, and I only have 1 flag left over, and that 1 is red, and there we go. And I multiply this out. I put them individually in the calculator, and I get 70 times 4 times 1. I have 280 ways in which I can do that. But another way I could have done this was using the repeating letters trick that we did yesterday. So imagine there are 8 letters, 8 factorial, and there are 4 one letter, 3 in another letter. You want to put the 1 on the bottom, it doesn't matter. You want to put parentheses in here, because basically what we're doing, we're dividing out the repeats. And if you put all this into the calculator, again, you get 280 ways to do this.